So I'm facing some network issues, that's why I'm connecting late. uh, I'm audible to you. Is my voice is clear? Can anyone respond in chat box? Can I think is my voice is clear? Can anyone respond in chat box? So based on your response only I can move forward. So can anyone do response in chat box? Just like put S if my voice is clear means. So I think I'm audible to you. I hope my voice is clear for you. Yeah, okay. So very good evening. Thank you for joining. So thank you for joining. So I'm facing some little bit network issue, that's why I'm joined late. So today we are gonna see 7 segment LED display. So basically 7 segment is based on the LEDs only. So each per each 7 segment display, it having the 7 LEDs up to like 0 to 7 means 8 LEDs. And then so by blinking that particular 8 LEDs, we can see some digits like 0 to 1 from one 7 segment display. So for controlling for controlling that particular 8 LEDs in 7 segment, we have tried code for that. So based on our logic, so it will display values based on our code. So basically 7 segments having two types of two types. One is a common cathode and another one is a common anode. So common cathode and common anodes are major types of 7 segment. So I will show you how it is work common cathode, how it is work for common anode. So basically yeah, thank you for joining in my 18th master class. So thank you for your presence. Very good evening to all. So let's get into common anode. So now in this today class we are gonna use common anode. So basically common anode is nothing but, so it is a 7 segment display. So you can see this is a 7 segment display looks like. So I'm having that hardware with I just connected my 7 segment with my breadboard and the FPGA by using jumper wires. So I will show you end of the session how I connected. So we can't connect the directly. So we know that if you give 5 volt or a high 5 volt or 3 volt 4 volt supply for LED means it will burst. So we have to use resistors. So we have to use resistor to glow the LED. So if I give directly means I will lose my LED. So I will show you how I connected in breadboard and how many jumper cables needed to make a one 7 segment display. So basically we having two 7 segments like a common cathode and a common anodes. So this is like a circuit diagram or circuit node for that 7 segment. So you can see here, so inside a 7 segment, so this is a shape structure like that. So here it have A means here it having one LED and B having one LED. So you can see this LED symbol. So it having 1 2 3 4 5 6 7 LEDs and also DP. So DP means that this dot point. So this dot point referring is called a DP. So this is also an LED. So we are gonna give input for one 7 segment. If you want to display some values like some numbers, some digit means you have to give up to 7 binaries. So if it is here like a, it will start from LSB. So imagine you having a 7 bit of binary, LSB to MSB having 7 bits. So first LSB bit is for A first LED, first LSB bit for first LED, and then second LSB bit for B, say second LED. So like a kind of things, like from the LSB side we have to count. So first binary is for A, second binary is for B, third binary is for C, so fourth, fifth, sixth, something like kind of things. A B C, it will come from LSB to MSB. So and then so there is a one logic here. If you are using the anode, common anode, we have to give the active low binaries. So it will on in the active low. So active low means, so is basically some FPGAs or works on active low signals. So active low means 0 means high, 0 means on, 1 means off. So it is like active low. It will work based on active low. So our FPGA board is also working based on active low signals. So if you take in some Spartan board also, Spartan FPGA also working on based on the active low. So Nexus 3, Nexus 4 or kind of boards. So and then you can see here common. So we having the 1 2 3 4 5 6 7 8 binaries, and then this is also important. You can see here common anode pin. So this is a pin. Why we are using means, if you having the lot of sound segments, so you can see this example, it having the 4 sound segment display. So I want to use particular this one. So it means, so this is anode, so these are the actually cathodes. So if you want to the common anode, so anode pin is for to choose the sound segment. So I am having the 4 sound segment here. I am having the 4 sound segments. I want to choose I want to use this sound segment means you have to choose. How means, by using, so if you like in your RTL code, you have to declare some anode like a 3 down to 0, and then you have to give 0 for the third, this particular second sound segment means you have to give active low signal 0 to this particular sound segments, then only it will select. So and then we can operate, or we can see some values in this sound segment. So if you are using if you want to use multiple sound segment, so here we having the 4. So if you want to access 4 means we have to use multiplexing. So multiplexing is nothing but changing the one sound segment to another sound segment with the delay. So if you want to, so basic thing is this anode pin. So this anode pin is for giving the choose the segments, sound segments. So this anode is mainly for to choose the sound segment. If you are having the multiple sound segment means you want to choose particular one means you have to give low for anodes for particular that particular sound segment. So and then so it having a binary. So if you want to print 1, so if you want to display 1 means you just have to give 0 here, 0 0 0, b equals 0. So like a second bit in binary, b and c you must give 0. It means remaining all bit have to give 1, so that only you can see the 1 in your sound segment. So let's see in this session how to write code for. So and then multiplexing. So multiplexing is the main important thing. So some particular clock, by if you using your FPGA board, you want to move you want to select like a firstly you want to see some values here in the first segment, and then you want to move the second segment. So we can't at a time. So main thing is, if you're using the multiple sound segment means you can't on at a time. So how to say, you can't on, so you can't all these 4 sound segments at a time. So you can only choose one, you can only choose, so you can only select one sound segment only at a time. So you can't on all sound segments at a time. So this is the main reason why we using the multiplexing. So the main reason is we can't on all the sound segments at the same time. We can choose only one sound segment, and then we have to move next one, and then we have to move next one, and then we have to move next one. So for this moving, so for this multiplexing we are using for this changing, so for this sound segment changing we have to use multiplexing. So multiplexing is based on the clock only. Some particular delay I'm just moving. So yesterday we seen that LED blinking. So per if your FPGA board having 50 megahertz means it will count up to 5 crore times at to make 1 second. To make 1 second it will count up to 5 crore times. So we have to give some delay. So at the 1 lakh or like a 10 lakh count, I must on this first 7 segment, and then next 1 lakh count I just on this, and the next 1 lakh count I just on this, and the next one 1 lakh count, 1 lakh count I just add on the third sound segment. So if I moving some delay with the 1 lakh count means, if you see in real time, it is visible like you on the all the sound segment at a time. So it's a, we can't see the delay, so we can't see the that 1 lakh count delay directly in the multiplexing. So it basically it will count 1 lakh and then it will move to next one. But if you see the, if you are seeing the real time, real time, you can see only like all the 4 sound segments are on. So I can see my some values here from the four sound segment. So this is the usage of multiplexing. So to make the changes from one segment to another segment very fastly by using the clock, so we have to use the counter. So based on the counter only it will move. So and then, and also we can give also clock divider. So clock divider and clock counter is not, it's not a different thing. So basically the purpose of both thing is same only, to make the delay to or increase the delay from the input clock oscillator. So and then we'll move to, so and one more thing here, you can see here, this is the anode part of LED, this is the cathode part. So if you can see all the anode part, so all the anodes are connected at the particular point. So and then you can see here it is a cathode of LED. So this there are 7 cathodes. So totally from and DP, if you add the DP means there are 8 cathodes. So this 8 cathodes only we have to give input. So I said no, already 7 bit of binaries, so I'm giving for the binary for this 7 cathodes only. So I am connecting the all anodes. So this is anode, so this is anode for this LED. I am connecting the all anodes at the particular point. So if I connect this means I can say this is the common anode sound segment. If I connect all cathodes at the particular point to choose the to choose the sound segment means it is a common cathode sound segment. So I already said no, it having 2 types, common cathode and common anode. So common anode means all the anodes of from the sound segment LED I connected at the particular point to choose this sound segment. So it is called common anode. If the common cathode, all common cathode from the sound segment LEDs I connected the particular part means, so at a particular point it is a common cathode. So and then for that, to choose the sound segments. So this is the difference between the common cathode and common anode. So this is LEDs, this LED for A. So it means 1 A B C D E F G. So we have to take into your mind while giving the binary inputs for the sound segment. We have to clearly give. So we have to give correctly, then only I can see the accurate number in my sound segment. So my FPGA is based around active low. So if I give B equals 0, C equals 0 means it will glow. Remaining if I give like A equal to 1, F equal to 1, G equal 1, D equal 1, E equal to 1 means, so 1 means off, 0 means on. So if I give B equals 0, C equals 0 means it will glow B and C LEDs. So I can see the 1 digit in my sound segment. If I want to see the 3 means I have to just on A, B, C, D, G. So I have to on these LEDs from sound segment. I have to give for 0, then only it will on. So I can see that 3. So this is the working of common cathode, common anode, and the multiplexing of sound segments. So this is a thing. So and then let's move to RTL code. Before going to that, so if you guys are really interested in this master class, you can convert this 21-day master class into 1 month internship on FPGA design. So these are the benefits you will get: all 30 days recording session, all 30 days presentation, exclusive project codes, VIP community group for your doubt clearing and internship updates. So and then you will get the internship confirmation letter from IETE, and also you will get the 90 days LMS course access. So and then assignment task, weekly live sessions, resume buildings. So resume building, we are giving some ideas to how to make a resume building. So and then we will give also mock test weekly live session. So and then you will get the end of the internship certificate, and also participation certificate from the 1 month of internship. So these all benefits you will get at the discounted fee of just 999. So our regular fee is 3999. So if you want to join our master internship program means you can use this registration link, and also you can find in the live chat box. So this limited time period offer, this offer will close at 5th March. So if you guys are really interested, you can use it. So let's move to the RTL code. So I already written code. So why? Because of so this is if I writing these binaries, it will take some time, so I can't so this it is simple only, just I written here. So you can see here I having two module. So here this is my input. So I just created my project. So this is my top module name segment. So this is a top module name. So this is my top module. So this is another module for decoding the binaries. So here I am creating the digits like a counter. So in this module I am going to create the digits, and also give the delay for the digit changing. So my this code is for to display the digits like a this code is for to display the values like from 0, 1, 2, 3 to 9. So it will count from 0 to 9 continuously. When it is if it is reaches 9, it will start from 0. So I will give the changes like from 0 to 1 changes. I have to give I have given like a 1 second 1 second delay for changing like for changing the 0 to 1, 1 to 2, 2 to 3, like kind of things. So for that this is my main module. So this is my main module. So I am having the clock input, and then output is a 6. I'm gonna use only sound segment. So I'm gonna use so I'm gonna use these 7 bits only, 7 like a 7 LEDs. So for that I'm taking like a 7 bit. If you add this like a dot LED, you have to give like a last MSB, like a last bit is last bit binary for this LED. So basically this first LED, so this is a 7 bit. So if you want to display 0 means this is a format. So this is for A, B, C, D, E, F, G. So this is 0. So this is a binary for 0. So binary values for display the 0 in sound segment. So this is for 1. So like you can see the first bit is refers to A and then B, C, D, E, F, G. So you can see here B and C I am giving like a 0 here, 0 0. Why? Because of I want to on this LED. My FPGA works based on the active low. So if I given like a 0 means it will on 0, B and C. So second and the third I am given like a 0 to display the 1. So this is for 2. So for that I want to just I want to on A, B, C, E, D. So I means it means third LED and then seventh 6th LED. So 6th bit I just want to off third and sixth bit. So for that you can see here third bit and then sixth bit I just off. So here it so you can see here low means on, 1 means 0 means on, 1 means off. So I just off my third bit and the sixth bit, it means I can see the 2 here. So and then so same thing for the 2, 3, 4, 5, 6, 7, 8, 9. So these are the binaries, common anode binaries to print the this decimal values. So why I'm using another module means I can use also inside this module. So just for clarification, I written in another module. So here this is main logic. My input is clock and then my output is 7 segment, that 7 bit of binaries. So and then so far you can see 6 down to 0 means 0 to 7. So 0 to 6 means totally it having 7 bits. So and then I am using counter. So why I am using this counter means I want to count, I want to display some value means I want to display 0 to 9. For that I want to create a digit. So for that I am using counter. So it's a 4-bit counter. So to make the 0 to 9 means we have to use 4-bit. So if you're using the 3-bit means it will count up to 7 only. So if you are using 4-bit it will count up to 16, okay, 15. So and then for that I am using counter and then clock divider. So for I am going to use counter for clock division. So yesterday also we seen like a clock divider, it will count up to 5 crore times to make 1 second delay. Same logic here. For that I am using another variable like a clock divider to calculate the delay. So here you can see here this is always block here at every passage of clock. So if my input clock is triggered or seen some edges passage means it will execute this always block. So firstly I'm just at every passage of clock I'm just creating, so I'm just incrementing my counter like a clock divider counter. So you can see here clock underscore divider is equal to, so non-blocking assignment, so clock underscore divider plus 1. So I'm just counting my clock divider. So and then so this is a main condition. If my clock divider reaches 5 crore, so 24-bit of decimal, so we can also just give like a just give 5 crore times. But if you writing 24 tick decimal 505000 means it will it is very easy to understand for others. So and then if it is reaches means I just create counter equal to counter plus 1. So this counter is for to make the digit. So and then once if and then it will come to this line if if the counter reaches the decimal line. So if I am just incrementing at 1 second delay, so if it is reaches if 5 crore times means it means it's a 1 second delay. So I'm after that I just increasing my counter. It will start from 0 and then I'm just add 1. So and then after this count operation, so after 1 second it will increase to already having 1 plus 1 2 and then 3 plus 1 4, like it will increase by 1 second delay. So if it is, so it will continuously increment up to 9. Once if the counter is reaches 9, so 4 tick decimal line, so once if reaches the 9, I'm just assigning counter equal to 0. Why? Because of I want to display only 9. So in each sound segment we can display only up to 0 to 9 only. If you want to display 10 means you have to use another one segment or another one sound segment display. So basically digit means one single digit means 0 to 9 only. 10 means it is a two digit, so we have to use another sound segment. So once it is reaches the 9 means I'm just resetting my counter. So you have to move to 0 and then start from that 0. So I'm just, you can see a counter equal to 0. So it after it reaches the 9, it will move to 0. It will start from that. So and then I'm also clock dividing, so I'm also giving 0 for clock divider. So for 24 tick binary 0. So this is the design, so top module. So here is I'm having another module for decoding. So here it having the two inputs, like one input and one output. Is a digit is a one input, and then segment is a output. So based on the case digit. So digit having some 4-bit values. So you can see here input of digit is 4-bit. So like a 4-bit means decimal, we can write, we can count up to 15. So based on the digit, if the digit is 0 means 4 tick decimal 0 means the segment will get the value like this. If it is digit 1 means the segment output, so this output will get the binary values like this. So based on the so I will tell you why I'm using digit here. So and then it's for decoding from 0 to 9 digits. So digit 1 for these binaries. So if you see the 4 means, so if you want to display the 4 means F, so it will choose like a this like a F, G, B, C. So I have to add like a second, third, fourth, sixth, second, 2, 3, 6, 7. So I want to add 2, 3, 6, 7 for 4. So 2, 3, 6, 7. So 0 means on. So 2, 3 on, 6, 7 on. So to see the 4 value in my 7 segment. So this is for digits, and then binary values I'm just giving. So and then so this is for my default value is all. My default value segments are all on. All on means it won't we can't see any values. It will display only. It won't give any values. Why? Because of high means off condition, off. So 1 means off. So in case n models, this is a one module. So I'm just connecting. You can see here I'm just instantiated my this module and then this module. So to connect the two modules, not only connect for testbench and design code, we can connect the two design modules also. So this is also design code, so this is also design module. I'm just connecting both them, but you can see some difference here. So this is the module name for my second module. So this is my second module. So this is my second module. So this is instance name, display. We can give any name for instance name. So display underscore instance. So and then you can see here this digit. So this digit is belongs to this module name. So this module, 7 segment module. So you can see here in this model it having inputs like a digit, but I am connecting. So these models inside the bracket I having some signal like a counter. It will from the current module name. So this module, so it will come, it will refers to current module. So here I am counter, so I'm just connecting the counter and the digit. So counter from this module, so it is not a signal, so it is not a input output signal, it is not in my port list, but I can use in my instantiation. It is one variable in my design code. So in this code, in this module, so it the counter variable, it having the values of digits. So it will count from, I already said no, you can see here it will counting from 0 to 9. So you can see this logic. So it will counting from 0 to 9. It having values like 0, 1, 2, 3, 4, 5, 9. So and then so counter it having values like a digits. So I'm just connecting both signals. So and then this segment was this segment seg underscore out from this module. So this segment is from the input, like input segment, so this module output. So I'm just connecting, so it will, so these segments having the binary values based on digit. So digit comes here, you can see here digit. So digit having the counter values, so I'm just connecting the counter and digit. So whatever it having counter, same value to having in digit in the module. Based on the digit value, it will choose the segment, it will give the output for segment out here. So I can see the values in my sound segment display. So this is RTL code for the sound segment. So and then let's move to pin assignment. So I already assigned my pin. So based by using the schematic, I just find my pins. I just assigned my pins. You can see here this is my pins. So this is a clock pin E11. So these are my pins. You can see here my input is clock only. My outputs are sound segment out only. Sound segment binary outs. So but you can see I didn't use any anode here. Why? Because of I'm having only one sound segment only, so I don't need to choose sound segment. If I give that so if I give this common anode pin to ground, means I can choose this. I can select this, so I can access the LEDs from this sound segment. If I given like a 0 or a ground or 5 volt kind of things. So this I just assign my pins. So and then I'm going to compile this. So just compile here. So I'm just compiling my sound segment. So and then I just compiled my code, and also let's see the how it looks like in RTL viewer. So this is the RTL viewer for sound segment display. So main output is this is the main output. So you can see here some gates like a active low, wide, or so this is some decoder. So you can see here I'm decoding my logic. So you can find here decoder. So this case, this case block. So you can see I'm using case block here. It will works like a decoding. So that's why I can see here decoder. So 3 input. So like a 3 down to 0 means 4 input. So you can see here digit. So based on the digit only it will decode. So decode it having the 4 bits. So you can see here for this decoder, it will all these like a schematic. It's created by the tool only. So this is a decoder, case decoder. So say 3 down to 0 means 4 bits. So my output is 16 6 down to 0. So my output pin is 15 down to 0 means 16 bit. So and then it will do some operate. It will add some OR gate and NOT gate to get my output. So this is a schematic RTL viewer. So this is a counter block 4-bit counter. So and then I will go show you another 4-bit another 24-bit counter. So it will count up to 24-bit wide range values. So let's dump the code into FPGA. So for that you have to go for, so you can also see summary of your project. So I'm just using 56 logical elements only. Total register is 24, total pin is 8. So and then you can see the percentage also, total memory bits, and then embedded multiplier, so 0 0. So you can see this you can see the summary for your project. And also I'm going to program my FPGA. So and then change file in the output, I'll just program my SOF file, SRAM object file. So and then click on program and config, and then click on start. So I think my USB cable is, click on auto detect. Here change file again. So I just program my FPGA, so I can see here. Yeah, and you can see here I connected my FPGA and my sound segment by using the jumper cable. So this you can see here I am using using sound segment, and I have registered lot of registers. So each and every sound segment, each and every LED, we have to use LED resistor, then only it will glow, otherwise it will last, it will burst. So I just, this is my FPGA. So I just connected my sound segment, each and every common anode sound segment by using jumper. So you can see some values here, 1 2 3 4 5 6 7 8 9. So here some issue in sound segments, this middle LED, it will glow but it will not glow that much, maybe some resistor issues there. So this is a way of writing. So then yeah, so that's all for today. And one more thing, if you want to connect, sound segment and FPGA, means we have to use a breadboard, and then there is some pin diagrams for breadboard. I will show you. So you can see here, though these are the pins. It having some this, we totally having 10 means like this 7 6 for A and B. So we have to give some proper connection, then only we can make correct, we can see the correct values. If I given like if I given some first bit binary to 8th pin, so it will wrong. So we have to ensure that we are giving correct pins, or we are connecting correctly by using jumper, FPGA and breadboard. So this is 7th pin, 6th pin for A and B, and then 4 5 for C. So 4 for C, so this 4th pin for C, this second and first pin for E and D, G 10 and 9 for GF. So common, you can see the common cathode, this example for common cathode. So it having 4 pins, we can use any one, so we can use any one from them. So from, if I give here, means I can select this sound segment. if I give some high for this means I can select this sound segment. So these are the pins it having. So if you want to use in breadboard, we have to know these values: 7 6 for AB, 4 for C, 1 and 2 for ED, and then 10 9 for F, G and F. So this is for today. I hope you guys are having some idea about sound segment. So thank you guys, thank you for listening. We'll see in the upcoming class. Tomorrow we are gonna see the stepper motor control. So how it is works, how to write the code, how to write RTL code for stepper motor. We'll see tomorrow. Thank you guys, thank you for listening.